Okay, so yes, on my behalf also thanks for inviting me here, and it's a pleasure to have a small talk with you on timber architecture and building some new forms out of timber. I think a few words about timber itself. As we noticed or saw there, you can do pretty much amazing stuff from timber, and even you can deliver quite amazing spans of timber structures while using just a normal truck and a couple of other wheels. But this is just one of the benefits. I think the big thing about the timber is that it's really kind of like renewable energy in a physical form. So it's just something that's grown from the sun and from the earth, and there it is, and it's really renewable. It will regrow, or it can be replaced another tree. And in that sense, I think forest is kind of like the manifestation of a green miracle, you could say. But as a material as well, it's like a very human. It is kind of like one that creates memories, but also something that records memories. If you look at this kind of like a cross-section of an old tree trunk, you can see how it's recorded, the different years it's been growing on the different conditions of water, different conditions of coldness, warmness, weather in general, the harsh winters, hot summers. And of course it's very appealing to eye somehow. It invites to touch, and it's kind of like really nicely reacts to the sound, and it's really kind of like softly seducing you by even the fragrance of itself. So there are plenty of reasons why to do things in timber. So I'd like to start with our recent project actually, which is kind of like a combination of stone and timber, you could say, and in that sense its basis itself or comes from the tradition of Finnish churches. This is a church in Ylivieska, which we won an open competition for, and been doing that for 2 years now, and now we got a green light for building it and should be open within 2 years or something. So the combination of stone and wood here is actually also maybe dictated by the history of Finnish churches, that everything that touches ground has been really heavy stone and kind of like very sturdy. And then on top of that there's been a wooden construction, which has been the roof and the rest of the church. But also in the new forms, of course, I mean, if you come from the traditional things, then the form has been there already. But I think, and I dare to say, that the new thing in here is that actually, because it has also the spaces of a parish center in it. So what our strategy was to kind of like make this three houses put together so that it's a one single building mass. And in that sense, it has the traditional elements of entrances, of sacristy and stuff like that, but it's all within a one roof actually, which is then making these triangular shapes in order to cover the whole basis. So other issue here is that we wanted to return to the kind of like traditional building physics. So it means that we build solid. So everything is single layered, whether it's stone, I mean then it's brick of course here, but then the timber, it's also single solid timber construction, mainly out of CLT, cross-laminated timber. And this is kind of like to give the endurance for several hundred years, and also kind of predictability of how the building physics really work there. But of course, architecturally, it's really inspiring that you kind of like go back to the times where you can make just a very kind of like embracing mass, and then you can dig out some places for people to be in there. And of course, structurally, that means that it leaves it pretty much open unless you just take care of the kind of like outer surface and inner surface of the spaces. Everything behind or within the mass, as long as it is solid, is quite free of design. But then, as you see it inside, can that be challenging, or can that be kind of like complex? I think it can in thinking of it, because then if we think how it's normally done in here, which it will probably be realized by, and I have a comparison of kind of a bit more further engineered ideas, how it could be also. just to give you a jump start for the future windows. So this is how it looks. So we have a kind of like almost a meter thick brick wall next to the ground or the earth. On top of that there is actually not continuous concrete beam, but a beam of concrete or column actually, which is always meeting the girders of the timber construction. They are about 6 meters of a span next to each other. The span of the church itself is about 30 meters in the width, and then the height is about 24 meters. So in Finland, that's a large-scale building out of timber. But there you can see that on the roof structure, there are no additional insulations used, only the CLT, massive CLT elements next to the waterproofing, and then of course you have ventilation, and then you have a brick roofing as a kind of like a thing that you see there and takes most of the water out. And this is the first time in Finland that the kind of CLT plates are used as a one unified plate in order to strengthen the structure and also taking the loads and taking care of the stability. But then could this be taken further still? Because I think, and we were having some talks before entering the hall here, that usually we are in a state of timber construction in Finland, kind of like that you take care of with one solution the forces that come down, then you have another solution for reinforcement, then you have a third solution maybe for some other layer. So it means kind of like many multiple layers. Of course it means maybe some other or combined selection of products, and it means combined selection of engineering details, whatever. So we had a chance to, actually this was done with the ministry, we had a chance to visit Switzerland for a workshop in order to create kind of like this bridge of knowledge between Finland and Switzerland in order to raise our level of engineering and architectural knowledge on how timber construction could be made. And it was really eye-opening event, and we had a one-day workshop there, and then after that they had 2 weeks of workshopping by themselves, and then they came up with the concept, presented it to us, and if you compare this to the traditional way, I think it's quite obvious that there is a lot of knowledge behind how things are produced, how can they be assembled at the site, and how the loads go. So all this together, so it's really a multidisciplinary solution for very complex systems with very simple solution, which is just one hollow box of a kind of like prefabricated module, which can then take care when it's rightly joined of all the loads, all the stiffness, all the movements, everything like that. And actually you can then, or what you really need to do and know is of course how to do the connections, joints in order to take care of the loads. But of course that was also handled there, and as you can see, everything is really neat, everything is really pure, everything is in line, everything is very Swiss, you could say. And then this is how it looks in a section, that this kind of like the hollow tubes, they go from the roof to the walls. And of course, I think if I remember right, after the production, this would have taken about less than a month to put up. So it's really fast as well. So there are things that we can go further on here in Finland as well, and as Johannes said, that I think this is really nice opportunity when you can see something that is being done abroad. Then you have the persons who are responsible for that here, and then you can exchange the knowledge and be open-minded on those. So I think gradually we can reach the level of the high-tech, let's say, on building timber construction in here, which means that you can have a very low-tech outcomes, which means material resources wisely used, and then time used very wisely as well. Okay. Then our architectural firm, we actually started with the Olympic Stadium canopy, and I wanted to show this because this is a very complex geometry, but it was done after all, I mean, after a very complex process and a very quite fast process actually, in a very simple form and outcome, you could say. So this was a competition as well, and then we thought about different options and went along with this kind of like form that is very flat on top, and then it has a kind of like this undulating surface so that it always meets the corners or the edges on the about being 40 centimeters high. So it's always the shape of the thing is always the same from the edges. And probably one of the key issues here was that why we won the competition was not the form itself, but also that we cladded it with wood, and timber has been actually always part of the heritage in Olympic Stadium when it has gone some exchanges at the site. So when it has been enlarged or there has been temporary stands or whatever, timber has been always part there. So there was kind of like the historical connection, even the benches were timber. So what it meant actually then, of course, the structure here, as we saw in the distillery as well, the main structure here was actually a steel structure, because the spans and the possibilities of anchoring it to the existing structures with timber, we couldn't succeed with that. But timber is thing that you see, and this taking care of the cladding of the shape itself. So we went to the wind tunnel test, of course, in order to find out the right geometry to investigate the effect of the geometry, to know the forces, structure, and then of course it comes to the details. But then we did a lot of one-to-one, let's say, study cases, because it needed to be prefabricated, because we knew the construction time was pretty fast. Everything we wanted integrated, so all the installations that you need there, it's a technical thing anyways, the canopy in the stadium, whether it's lighting, loudspeakers, stuff like that, we wanted that to be integrated, and this shows you our tryouts and kind of like ideas how to integrate it so that it's kind of like continuous surface without any interruption of these technical things. Then scale is always important, so we were thinking how to do this kind of like a big scale surface out of timber, and then in order to get certain quality, and then we realized that it's possible actually with the industry, so that you can use the worst possible quality of a timber if you then just cut it into small pieces enough, so you get rid of the branches and bad placing parts and stuff like that, and then you use the finger joint, and what you create actually is as hard wood or a structurally tensile wood as the timber itself. But then we also layered this in 3 layers in order to keep some sustainability against the moisture, so it doesn't twist there. So this was kind of like our first attempt to do this future craftsmanship, which was our idea too, that you have the quality of the craftsmanship, but it's industrially produced. And of course, then you have to take care of the width of the prefabricated stuff. And here I think they were 12 meters, 12.8 meters long, about 1.2 to 2.4 meters of a kind of like pieces. And then while they were put to the place, actually it's kind of like you would use some canvas or something. It's so, even though it's very heavy and it's very materialized, it's actually very flexible at the site during or because of the dimensions. So we were able to create this unified surface which met the challenges of geometry, and this was prefabricated. So now we are back at the crime scene actually. We are just finishing the project, or it should be finished, the refurbishment of the Olympic Stadium next summer. Has extended, as you can see, actually it has extended in many directions. It has extended to the curved parts of the stands, but it also has extended on top of itself in order to get a longer spans of the columns, so that we won't disturb the spectators. And then you can see the effect that in the original one, in the eastern part, there were seven columns, and now actually we can do 5 here at the south and 6 on the north, which means that longest spans are about 36 meters. But then, of course, the structure is not the issue here, because it's again a steel structure for the same reasons, continuation of the old one. But the cladding is then, and here we then studied the same issues that I showed you earlier on. But now, because of the scale, because of the geometry changes, geometry is changing also so that it gets narrower when it goes to the end in width as well. So that meant actually that many of those lines which are continuous, they started to end. And how to deal with that? So of course, one issue is where do you start? So we decided that you always have to start in front, because that's the thing that you can actually conceive, and you can see that those lines, if they are not working very well or they are ending next to the edge, then they are visible. So then the black cut in between there, which is taking care of
all
the installations, that was the place to hide the kind of like non-continuous strips. And then again we have another starting line in the back of that strip, and then it goes to the back of the stadium itself, where you can end it how you want, because it's kind of like the geometry there is changing anyways. But then the other issue was, that was one thing, then the other issue was that should it be prefabricated or not. We had a lot of discussions and tryouts with the prefabrication, but because there were so many geometries changing within even one prefabricated plate, so it was decided that actually the unit that we use here is the 5.5 meters long strip of this wood, and that's it. But then there's another complexity here, which is actually that it has to take care of the fire issues. The original ones was sprinkled actually, so there was kind of like the system for that. But then, of course, if you think about winter and maybe winter use and water, and they don't go very well together. So the client did not want to have that sprinkled anymore. So we had to find out some solution for the treating the timber. So one was of course painted somehow so that it's fire resistant. The trouble is that you probably end up painting it every 5 years. Maximum, mostly every second or third year. So what we found here was kind of like we had this innovation series of innovation meetings where the timber production people could come to us and talk with us. And then we found this stone wood, it's a kind of like a timber which is impregnated with the kind of like this stone, what do you call it? Well, the ingredients of stone itself, which are then staying in the cells of the timber very firmly, and that means that it will last there for 50 to 100 years and it won't burn. So, but it needed a lot of processing actually in order to come with that. And then actually I think now what we have redone there, I think we have achieved even a better solution, because it's really, when it's done at the place, you only have, let's say, 5 discontinuous lines, which takes of course the care of the movements of the moist and heat. So that kind of like that was a learning process for us, how to do this kind of like cladding in a very abstract expression, but still technically working and being cost effective enough to be realized actually. Then that kind of like study line has continued on. This kind of like cladding has been then exposed to the shipbuilding tradition. Then we have used it for the marking the kind of like a public building for the community in Maunula, and then it's been hovering on the visitor center of Fazer. So that has been used also for branding, but in all of these projects we've been able to use some of the knowledge or go further with that knowledge actually that we gained from the Olympic Stadium project. Then I will take you a bit more further on the project that actually has a really complex geometry and has a complex, let's say, content as well, which is the Kamppi Chapel actually. And I just wanted to show you that the process started, it wasn't so clear how it will actually appear at the end. So we have a lot of tryouts with different models of different versions of geometry. What it was kind of like stated from the client that it should be timber construction, it should be place for silence, it should have some meeting rooms for either social workers or the priests in order to meet them, and then rest was pretty freely up to us come up with a solution. And the place in Kamppi is really tricky because there's kind of like height differences there. There are a lot of big people flows going into the metro station, coming from the railway station. It's kind of like most commercial place in the Helsinki as well, and how to do this place for silence in there, that was a challenge. Which then we thought that we should somehow create a form that comes out of the of that context, that it's a place for silence, for the material and light, and then it allows these people flows to pass by. It also allows the kind of like eye to pass by. You see it there, but then it doesn't block your views actually. And then of course it was really important that we wanted to make it real wooden on all the surfaces, so that it's a really abstract intentions of bringing something pretty different which was existing there, which is of course glass and stone and metal and stuff like that, which you usually find in commercial architecture. Then it was partly built in situ, partly prefabricated, and I will show you how. But this was then the main concept, that all the kind of like additional or service spaces that we need, they are put next to the ground actually, so it's kind of like continuation of a ground, or the height difference that you could see there, and then the real thing that you see is only the chapel itself, and the form of that is such that it kind of like covers itself from the outdoor noise, and it's visible strong enough in order to withstand the kind of like weight of the very tall commercial buildings. This is size of a single family house. It's altogether like 350 square meters. So that was a kind of like tricky thing, that how to do that in timber and not make it look like a single family house, because of course that would have been not fulfilling the criterias. But then the concept itself was quite clear, that we needed to make a shape which kind of like covers itself from the outside noise. It takes in light as much as possible. It's kind of like a place for silence, and then there is only material which is present there. So this section gives you the idea of that. Then of course all that is black in there, even with the timber construction. This is kind of like similar situation that we have now in the Ylivieska church, that all that was kind of like a free playground for construction or engineering, how to do that. And for that we had several different rounds of course, but then the one important issue for us was that, as I told you, because it's a very small in size, so the expression or the impression that you get from it when you see it there should be really abstract, and we thought that it's really important that you don't pay attention to one of the strips of timber, but you just pay attention for the surface, the whole kind of like the form there, which meant then that there needs to be quite a lot of lines. We did different scale testings, and then of course then the next question, which will come a bit further on, was that how to do that so that every line is horizontal actually there. And by doing these drawings we were not aware of how difficult actually it could be. But still we fine-tuned the shape within the context, made some differences to the orientation, and then if those models were 1 to 200, then I think it was really important we jump into the 1 to 50 scale, because then it's a scale of almost doing, I mean, then the building, which is of course building is building, it comes out of the context. You should never do it as a design, but there are moments where you have to kind of like detach that and take the kind of the form of the building itself into a kind of like an abstract idea of just the form. And this 1 to 50 scale model was actually very helpful in that, because it was made out of plywood which was glued on top of each other, so there we could actually then reach again the same tactileness on the texture that we wanted. So it's always important to keep the goal present there. So the lines were again important, and this showed that it's possible to have this always differently curving shape and still the lines are going straight. But also, I mean, the whole shape of it, that we decided then for reasons like we saw there, that if you want to protect itself from water and stuff like that, it should be something that always grows and protects itself, and you can't detect those shapes without making a real model out of that. And we redid the design based on this model with some corners. But then of course the shape itself started to reflect that, and we started to discuss how to do the cladding itself, or I mean how to use the timber. And then of course we started talking with the people who are either contacted with timber industry, or then they were really craftsmen of timber, like carpenters. And then of course this traditional boat came up, and then if you look at the layout of the traditional boat, so it resembles like a building. So, but the part is there actually that while the kind of like the lines start to follow the geometry, it means actually that to make that thing that you have to cut each of those boards in different forms, and that we realized. And then if you think about the layers of line we had in there, and we thought that maybe the scale should be that if we use this high of timber, it means that it's kind of like the single family house again, because that's the scale that they use there. So we had to do something else. So it had to be this kind of a visible dimension. And then if you think of reshaping that kind of dimension, and I mean hundreds of layers of those, so then we realized quite soon that this is not the way to go. What can we do? So then, as we saw earlier on, we also had some geeks in our office, luckily. And so this is just graphic to me, but of course I understand where it comes from, but I cannot actually make this. The next one, this I could even make maybe. But then so we had this geometry in BIM model, which was helpful of course in many ways, but then we had these surfaces of the inner surface and outer surface and things in between, and of course then we made this diagram of programming and the programming was used to cut this shape into the vertical slices in every 600 millimeters, because then we realized that if we don't want to reshape the horizontal lines, then we have to make the vertical lines individual in order to be able to use just standardized horizontal strips. So after that, this is kind of like a notation or the graphic that we got there. So the idea is that each of these vertical secondary structures, which are then just used for installing the cladding, they are different in their shapes, they are different in their radius, but also the kind of like the cutouts are different because of the directions they are facing. So that took care of the secondary structures. Then there was the cladding still, and based on the experiment that we had early on, we very early on decided that we will go again to this three-layered glued of facade material. We think about what kind of timber can we use, whether it's spruce or pine. Then we went for spruce because it's actually pretty much moist resistant and acts better in the facades than the pine that we found out. And then because it was industrially produced, again we could get high quality spruce out of non-quality spruce actually. But then there was still this issue that how to kind of like somehow try to organize the cladding so that you don't have to spend half a day just thinking of how to do that and of what kind of like timber parts to use there. So we made again, by using the computer study cases, kind of like this, the redder it gets, the steeper the radius is. So kind of like these hotspots showed us the critical points of the geometry itself. And based on this, actually, we had about 10 different pre-bent shapes as a result. And then they went for the production, and then I think the critical point was the most steepest radiuses, of course, because then if you make them not facing that very well, because then you have to force them quite a lot at the construction site, that means that they may withhold for some time, but when they start to react to the moist and temperature differences, then they start to crack. So those were the critical ones. Then these are easier ones where you just can follow. But of course, that we had learned in a stadium project, that when you make them long enough, then it's almost like a wire, so you can pretty much bend them in each direction. Okay, so it was based on that. And then there was still left at how it should be actually that we make the cladding itself. Here, by the way, see the section of the wall construction, and it's a multi-layered construction in here with a different section shape in because of the taking care of the noise. And that means that while you have a different width to that wall, it means that it takes out different wavelengths of a sound. So it really works pretty well for the outside noise. But of course, while you're in a chapel, you want to have a kind of like chapel kind of acoustics. So you really need a mass again in order to get your voice echoed back, get the feedback from your own voice. So that's why actually this massive common alder free-floating inner core actually placed in there, which is then the visible chapel itself. But then the outmost cladding behind of what, of course, is there's a kind of like the raincoat, which is very heavy raincoat used in kind of like weather-exposed buildings that could have been left exposed, but of course, for the architectural reasons, we wanted to use the cladding, and then we started with the traditional cladding where you have kind of like the water drops taking care of this kind of like a small slot in here, but then we made one-to-one mock-ups, which I will show you there, and we realized that they became too weak because the edge is then very vulnerable for somebody hitting, and then we created this shape of kind of like a twisted rectangular in order to take care of that water always drops in here and it's always ventilated, so that should give the best durability for the spruce cladding as possible, and then taking care of the fixing so that it's not exposed to the weather and of course exposed to the eye. And there you can see this was the idea of using this very small scale cladding in order to make the surface the thing, not the cladding itself or the parts of the cladding. So then a lot of tryouts. Actually for the inner massive wall there was Kari Virtanen, who was a very well-known and very experienced carpenter. He actually came up with a system that if you have kind of like this size of or piece of wood and then you cut that in a curved form and then you put actually the flat parts together, you get the shape that we wanted. But then again, this was a program for the building time for this was about 1 year. So then we soon realized that if you start to do that, you have a pretty much individual pieces put together. So what we did was actually a similar kind of solution, but CNC milling, and actually that could be very easily, again, by using computer, being organized so that each of the elements, like we saw in Johannes' presentation, they were numbered, and then we did some pre-assembly and some tryouts, and it proved to be a really good thing because when you had your hand going on in there, you couldn't feel anything because it was so precise, the CNC milling. And then only thing was to take care of, again, that the joints, they are never facing each other, so that you have kind of like this randomly, but still running kind of like a line of joints in vertical direction. And it's really a massive wall. It's been then, when these elements, which are this size of approximately, were brought to the place, they were numbered, so they started to laying them, and each layer that was laid, then on top of that came the second one, and they used glue again and then some screws in order to make it really, and then now what you see in there is really a kind of like solid, free-floating timber construction, which is detached from the outer core in order to give no vibrations to get the noise. So, as a finished building, you can, I don't know, maybe some of you have visited in Kamppi. It's open from 7 to 10. It has been really popular. One of the, I think, top 3 tourist attractions now in Helsinki. But the issue was not to make a tourist attraction. I think what's really nice is that we are now working with the Helsinki-Paris Center now in order to find out some new places where you could have more meeting rooms for the social workers and for the priest, because that has been the really... She was helping me. Thanks, Siri. Maybe she heard the word Kamppi or chapel or whatever. Anyways, so there you see it finished, and then as you see, all the kind of like the supportive spaces are put back to the black wall, which is kind of like extension of the old city wall, and then you have the chapel in there, and as you can see, the only thing that you really see is the surface and the shape, not the single parts of that. And then there was some experimentation done in here. Of course, the durability of this, because it's not paint which is covering the timber totally. As you can see, it's kind of like this. The timber shows through it, so and it's not varnished, but kind of like that. So we had a company, actually it was Technos, who had this kind of like biowax created at the time, where they had this kind of like nanotechnology for the basis of this treatment in order to give some water resistant for that. And now I think it's been there from 2012, and it's still pretty intact. There are parts which have now been getting some where you can see some aging, but it's normally redoable, so it should maintain there for the several year hundreds, I guess, as well. And here you can see also it was not only about taking the water drop down, but it was also to create this kind of like architectural intention of the lines, because then the thing that we created, when the edge is always coming on top of the other one a bit further on, so it actually creates quite sharp lines in the contrast of light. And inside, the idea which we could then come up with this kind of like industrialized craftsmanship was that we really create a place where it's only material, silence and light. And I think this, the way looking now back and actually being on the other room before this event, I think which is really nice in here, that somehow now I feel that with these technologies that we saw in the early on and with this Kamppi Chapel, I think now Alvar Aalto's idea, which he then came up with in Cultural House, with this kind of like one shape of a brick, which was trying to make kind of like every corner possible. So he was talking about this elastic standardization. So I think now that we have the tools for computing, we have tools for production, we are pretty close to that, because it doesn't really matter how do you shape those things, or how do you put them together in complex forms, if it's just well thought over beforehand. So it means that we really need to do a lot of thorough research and design, but then we can achieve pretty amazing stuff that used to be achieved only by craftsmanship earlier. But yes, thank you.